And Smith chart, it is a very powerful tool to analyze transmission and at high frequency. And Smith chart is not like your normal graph. It is going to be a graph which is drawn based on the reflection coefficient. That too, you don't call it as a normal reflection coefficient. You call it as a normalized reflection coefficient tau. Usually tau is equal to ZL minus Z naught by ZL plus Z naught. So you divide both numerator and denominator by Z naught. So you get ZL by Z naught minus 1 by ZL by Z naught plus 1. See, whenever you divide any impedance by Z naught, it becomes normalized impedance. So it becomes ZNL minus 1 by ZNL plus 1. So if you consider this is the tau to be having some real part and imaginary part A plus JB, and ZNL will be having a real part and imaginary part if you cross multiply and if you separate the real term and imaginary term. So that will beautifully come to an equation of circle. So that derivation is actually a part of UG. So in PG, we don't have the derivation. We just have to understand that the basic Smith chart derivation starts here. So it is like if you know that tau of a network, you can entirely decode what is the behavior of the network. That is speciality of Smith chart. And we have a family of curves representing Smith chart. So we have constant resistance circles and constant reactance circles which are plotted on the Smith chart. So when you overlap these two circles, constant resistance and constant reactance circle, you get what is called a Smith chart. And Smith chart is completely based on the reflection coefficient and not based on the actual impedance. So that should be very clear. So whenever why we are going for Smith chart, why we are not directly plotting with impedance, that is whenever you try to create an open circuit, your impedance value will go to infinity. So where will you mark infinity in the graph? So that is a trivial question. So in that case, but in Smith chart, when the impedance becomes infinity, you have value of reflection coefficient. In open circuit condition, you have the value of tau. In short circuit condition, we have the value of tau. That is a very simple reason why we are going for Smith chart in terms of tau. So plotting tau instead of impedance will have control. We'll have control over the Smith chart. And maximum value of tau is 1, minimum value is -1. So tau value is also limited. So when you're plotting everything with respect to tau and tau value is bounded, our graph becomes very flexible. Our graph also becomes bounded. So even infinite resistance can be brought into Smith chart in a simple coordinate. So that is the beauty of Smith chart. And you know that for every lambda by 2 cycle, the tau is going to be repeating. It is a periodic quantity. It repeats every lambda by 2. Okay, so it's just like how when you complete one full cycle, 360 degrees, you come to the same point, right? So same way, tau also, it is going to repeat after every half wavelength. So we can say that if you cover Smith chart one time fully, it corresponds to 0.5 lambda. So that is the logical understanding. So when you have so many constraints like this, instead of plotting the impedance, plotting tau is going to be a logical question. So when you derive all equations in terms of tau, when you solve the equation and get the equation for circle, that is going to be your